Hello everyone, welcome back to class 9 mathematics, and I am your Anu for mathschool.1. Last class we have been seeing chapter 2 polynomials, isn't it? And I have given some points on polynomials and the types of polynomials, and in the last class we have seen the roots of polynomials and zeros of polynomials. What do you mean by roots and zeros of polynomials? Let us recollect them and we'll move ahead with polynomials. Okay. Now we have seen that 3x plus 5 like expressions have degree 1, isn't it? The variable has degree 1, so these are called linear polynomials. I have said these are linear polynomials, and like 2x squared plus 5x plus 3, like these expressions, they are called quadratic polynomials because the degree is 2 here. The maximum power is 2, so it is called degree, and the degree is 2 here. They are called quadratic polynomials. And the polynomials like 3x cubed plus 2x squared plus 11x plus 2. So these types of polynomials are called cubic polynomials because the highest power or the degree of the polynomial is 3 and we name it as cubic polynomial, isn't it? Now let us see how these polynomials behave. Now let me take a value for x. Let me take x is equal to 1. Let me make it simple. So x is equal to 1. I am taking x, as I said before, x is a variable. It can assign as many values as it can, isn't it? So x is equal to, when I put x is equal to 1, see what happens? 3 into 1 plus 5, and we get that to be 8. 3 plus 5, that is 8. And in case of quadratic polynomials, we have 2 into 1 square plus 5 into 1 plus 3, that is 2 1 squared is 2, 2 plus 5 is 7, 7 plus 3 is 10. And in case of the cubic polynomial, it is 3 into 1 cube plus 2 into 1 squared plus 11 into 1 plus 2. So that is how much? 3 plus 2 is 5, 5 plus 11 is 16, and this is 18. Now what are these numbers called? 8, 18, 10 and 18. They are called values of the polynomials. See, they are called values of the polynomials. Okay, so this is what we call values of the polynomials. By substituting some value for x, I get the total value to be a number. So as the case x is equal to 1, this is a positive integer I have assigned to it, but it may not be positive integer, it can be any real number. X can, as I take values of any real number. Okay, so the x cannot be represented as, the powers should not be negative numbers, or it should not be in roots. So that is the condition for polynomials to exist. But the values assigned to x, the values given to x or substituted instead of x, can be any real number. Okay, so that is what we call value of the polynomial. Now if at all I have, see, instead of getting some value, I got 8, isn't it? Instead of getting some value, if I get 0, see, if at all I get value 0, if the value of the polynomial becomes 0, then there should be some value for x, isn't it, for the equation to be 0. So this is called an equation. Actually, this is called an equation because this linear polynomial is equated to 0. So this is an equation. We have a left hand side, we have some expression, and right hand side there is a value, and we equate it, so it is called an equation. So in this equation there has to be some value for x which makes the linear polynomial to become 0. So the value of the polynomial becomes 0. So that value of x is called the root of the equation, or 0 of the equation, or it is called the solution of the equation. So what do we mean by solution or 0 or root? The value obtained for x, or the value we substitute in x such that the value of the polynomial becomes 0, is called the root of the equation, or 0 of the equation, or solution of the equation. Now let us see what is x here. in the linear polynomial for it to be 0. Now let us substitute. I can directly find out x, or I can do it by trial and error method too. See, now I put 1 and check. So this becomes 8 as we did before, isn't it? Now all the numbers are positive numbers. So when I substitute a positive number in x, it will not become 0. So I try some numbers like 3 into minus 1 plus 5. So what is the value? Minus 3 plus 5. So it becomes 2 now. From 8 it has become 2 now. So let me put minus 2 plus 5. What it becomes? Minus 6 plus 5. It goes to minus 1. See, 2 and minus 1. In between there is 0. If I substitute minus 1, it is 2. And if I substitute minus 2, it becomes minus 1. So 0 in between, 0 is in between 2 and minus 1, isn't it? So the value lies between minus 1 and minus 2. So that we know it lies between minus 2, minus 1 and minus 2. So for these reasons, how I can find is, I take the equation 3x plus 5 has to be 0. So what is the value of x? 3x is equal to minus 5, or x is equal to minus 5 by 3. I bring 3 to this side. So that is minus 5 by 3. In the last class I have explained to you what is transposing. See, here plus 5, to cancel the effect of plus y, I add minus 5 here and minus 5 there, isn't it? So minus 5 plus 5 becomes 0, and here it is minus 5. Again I transpose 3 here. See, I divide 3 here and I divide 3 here too. So if I divide 3 here, 3 gets cancelled, you get x here, and minus 5 divided by 3 is the value of x. When substituted here, will make the equation 0. So the root of the equation, or 0 of the equation, is x is equal to minus 5 by 3. Now you understood what do you mean by 0 or root or solution of the equation? Yes. Now in case of that quadratic equation, the same trial and error method can be applied first, or otherwise a trial and error method can be applied, or if at all we can apply the splitting the terms method, that is we did in last year, isn't it? Where you would have, if you remember, you would have it would be easy for you to recollect what do we mean by splitting the middle terms. Even in the last class I told you about the splitting the middle terms. But let us say 2x squared plus 5x plus 3 is equal to 0. Let us take it. So I need to find the value of x which makes this equation, which makes the polynomial, quadratic polynomial, to become 0. That is, let me take minus 1. X is equal to minus 1. So I get minus 1 the whole square plus 5 into minus 1 plus 3. So what is the answer? 2 into minus 1 the whole square is plus 1. So 2 into 1, 2, minus 5 plus 3. See, 5 minus 5, this becomes 0. So one of the values is x power minus 1. Why do I say one of the values? Because if the degree of any polynomial is n, then there are chances of n roots in existence. Okay, what do we mean by this? If the degree here, see, if the degree is a power x n plus b power x plus c, some n is there, that is x cubed, it may be a cubic polynomial, or generally polynomial more than the degree may be more than 3 or 4. If it is n, the degree is n, then there are n roots. So that is one theorem. The theorem states if the degree of the polynomial is n, then there are chances of the existence of n roots. Okay, so there are n roots for degree n polynomials. So now we have x is equal to minus 1 as one of the roots. Now the next root is, we'll try to find out minus 2. Let me put x is equal to minus 2 the whole square plus 5 into minus 2 plus 3. So 2 into 4 I have plus minus 10 plus 3 8 plus 3 minus 10, that is 11 minus 10. No, it is not 0. This is 1 actually. Now the next thing is, let me take now let me take 2, this is minus 2, isn't it? Now let me take minus 3 plus 5 into minus 3 plus 3. So this becomes 2 into 9 minus 15 plus 3, that is 21 minus 15. No, it is not, that is, it gives you 6. So we keep on trying until we get 0. So up to what we can try? So that is the question. So x is equal to minus 1 here. To what we can try? So that is the question here. See, x is equal to, let me put so 2 into 25 minus 25 plus 3. No, it is not. Okay. Now let me check. 2x squared plus 5x plus 3. Okay. Now let me see. See, I said in the last class we need to multiply the extremes. That is the leading coefficient. This is called the leading coefficient and this is the constant term. Okay. So I multiply these two. I get 6. The product is 6. And the this has to be 5. So the product has to be some, I said I take some numbers p and q, so that the product of pq is 6 and the sum of pq is the middle term, that is 5. Okay, so that will be easier. Then we'll substitute it and see which number. So okay, so pq is equal to 6 and p plus q is equal to 5 we need to get. So what is this? So p plus q, 2 plus 3 is equal to 5 we have got, and 2 into 3 is 6. Okay, so this becomes absolutely correct. So what I need to do is 2x squared. For 5x I write 2x plus 3x because that is what we got, plus 3. So 2x squared plus 2x plus 3x plus 3 is equal to 0. Now 2x I take as common, x plus 1 here, isn't it? 2x into x is 2x squared and 2x plus 1. Now just copy this x plus 1 this side. Okay, x plus 1, just copy this x plus 1 this side and see what has to be multiplied with x, plus 3. So plus 3 into x gives you 3x and plus 3 into 1 gives you plus 3. That's it. So now we get, see, x plus 1 is common here. So I take x plus 1 out and 2x plus 3, isn't it? Do you understand? So x plus 1 is there. So you take x plus 1 common and the other, the left out is 2x plus 3 which is equal to 0. Now here I have either x plus 1 is equal to 0, which means x is equal to minus 1. So I've got this, isn't it? I've got this. The second one is 2x plus 3 is equal to 0, that is 2x is equal to minus 3 or x is equal to minus 3 by 2. So we are getting it in fraction. The other number is x is equal to minus 3 by 2 is in fraction, but we won't be able to find out by trial and error method. We will be substituting 1, 2 and 3 minus 1, 2 and 3, but we will be seeing within what range of whole numbers we will be able to get the number, isn't it? Within what range we have 0, between which two numbers we obtain 0. So we need to fix those two numbers and we can find it out, but it will take a long time. But by doing like this, you will be able to find out the zeros of the polynomial very easily. Okay, so this is one of the method. By splitting the methods, I can find out the roots of the polynomial. This is what I have done to show you that quadratic polynomials have two roots or two solutions. Okay, so this is about polynomials and zeros and roots of the polynomials. I have explained it still more clearly to you. Now when we do examples or when we do exercises in these zeros and roots of the polynomials, we will be able to understand more about them, and we'll continue with each and every method by which we can find out the zeros or roots of the polynomial. Okay, so this is about what we have done, zeros and roots of the polynomial. And the next one we are going to see about is two theorems regarding polynomials, the remainder theorem and the factor theorem. See, last class I have given you the general form of a polynomial. The general form of the polynomial is an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 and so on. A 2 x to the power 2 plus a 1 x power 1 plus a naught and x naught x to the power 0, but x to the power 0 is anyway 1, so we get a naught. This a naught is the constant term and this an x power n is the leading term, where leading term an is a leading coefficient of x power n we know. So an is any real number, this a is any real number, and this n is also any, this n is a positive integer we know, because negative integers are not allowed and fractions are also not allowed. So this a, let it be any real number. So this is the general format of the polynomial we know. Now if at all there is a I say there is a factor like x minus a, this is a linear polynomial, x minus a is a linear polynomial, and this linear polynomial, the condition for the linear polynomial is the degree should be 1. Okay, so the degree should be 1 here. If at all there is a factor x minus a, factor means this x minus a divides the polynomial, given polynomial of any degree, more than, it should be more than 1, it should be more than 1 or 2, 3 or quadratic polynomial or cubic or more than that, it can be any polynomial, this polynomial. If x minus a is a factor of the given polynomial, this polynomial is represented as f of x. So a factor of f of x. If this x minus a is a factor of f of x, then f of a, see what is f of a, we put x minus a is equal to 0, we get x is equal to a. So we have value for x from the factor and we substitute that a in f of x. See, in x, in the places of x, we substitute a. Okay, I said a is any real number, so this a is substituted in the given polynomial. In the places of x, we substitute a, and if that f of a becomes 0, okay, sorry, if you have f of a, if you have some f of a has, it is some value, let us take it as alpha. Okay, let us take it as alpha. If you substitute this a in the given polynomial, you get some value for f of a, isn't it? You have some number, then that value, that alpha is called the remainder of f of that division, that is f of x. This f of x, if divided by x minus a, if you get some remainder, and that will be equal to f of a. Do you understand? If x minus a divides f of x polynomial, then f of a is the remainder. Do you understand? It can also be 0, the remainder can also be 0. If the remainder is 0, see, if I said that if it has some value, if it gets some value, like if you get minus 2 or 3 or 1 by 2 or 2 by 3, any number, it is alpha, that is denoted by alpha, I said, it's some number it takes, then that will be the remainder when f of x is divided by x minus a. Okay, but if you get 0 in the place of alpha, if you get 0, then what does it mean? If the remainder is 0, what does it mean? Then x minus a is a perfect factor. It perfectly divides f of x, and that is the factor theorem. Okay, if x minus a exactly divides, is a perfect factor of f of x, then f of a is equal to 0. If f of a is equal to 0, we say that x minus a is a factor of f of x. Or if f of x if f of x minus a exactly divides f of x, then we say f of a is equal to 0. So that is what we call factor theorem. Okay. So how a linear polynomial is defined as a factor of a polynomial is that x is equal to x minus a is substituted to 0, and we get the value for x is equal to a, and that a is substituted in f of x, and if the value is 0, when you substitute the value of a in the places of x, if you get an answer 0, then we say that the linear polynomial x minus a is a factor of f of x, and that is called the factor theorem. So for both factor theorem and remainder theorem, we have a linear polynomial and we have f of x, a polynomial here, and this x minus a divides the given polynomial. Okay, if it is not a factor, if it is not a perfect factor, if this linear polynomial is not a perfect factor, you get some remainder, isn't it? That remainder, without division, we can find the remainder. How? By substituting a in f of x. We get some value, and that is remainder. If you get an answer 0 when substituting a in the given polynomial, if you get the answer 0, then we say that x minus a is a factor of that polynomial. Do you understand? So this is the general expression or the general representation of the theorem, the remainder theorem and the factor theorem. The next class will be seeing these two theorems, remainder theorem and the factor theorem, through some examples, so you will be understanding it more clearly. I'll be explaining it, I'll be explaining the theorem as well as I'll be giving you some problems. We'll work on it and you will understand it more clearly, what is remainder theorem and what is factor theorem. So until then, this is what we have done today. That is, we have seen what are the values of polynomial, zeros of the polynomial, roots of the polynomial, and we have also seen what is remainder theorem and factor theorem generally. Okay, so that's it for today, and we'll meet in the next class for more about factor theorem and remainder theorem in the chapter polynomials. Until then, it's bye from Anu for Mathschool.1. Thank you.